continue with our physics course. Today we will see the two-dimensional motion on vectors, but only the theory part. Practice part will be our video number 2. As always, you have the exercises so that you can check your answers of the last video. Now, today's topic, Introduction to Vectors, Scalars and Vectors. Vectors indicate direction, scalars do not. Each of the physical quantities encountered can be categorized as either a scalar quantity or a vector quantity. A scalar is a quantity that has the magnitude but no direction. Examples of scalar quantities can be speed, volume, and the number of pages of a book. A vector is a physical quantity that has both direction and magnitude. Displacement can be an example of a vector quantity. Vectors are always represented by bold-faced symbols in this course. As you can see in the figure of the two soccer players here, the length of the vector arrows represents the magnitude of these two soccer players and their velocities. Let's continue with the next part of the video. A resultant vector represents the sum of two or more vectors. When adding vectors, you must make certain that they have the same units and describe similar quantities. For example, it would be meaningless to add a velocity vector to a displacement vector because they describe different physical quantities. Similarly, it would be meaningless as well as incorrect to add two displacement vectors that are not expressed in the same units. For example, you cannot add meters and feet together. Continuing, vectors can be added graphically. Consider a student walking, as in this figure here, 1,600 meters to a friend's house, and then 1,600 meters to a school, as shown in the figure. The student's total displacement during this walk to school is in a direction from his house to the school, as shown by the dotted line. This different path is the vector sum of the student's displacement from his house to his friend's house and his displacement from his friend's house to school. How can this resultant displacement be found? One way is to find the magnitude and direction of the student's total displacement is to draw the situation to scale on paper. We will solve exercises to explain this part in the next video. Continue with properties of vectors. Vectors can be moved parallel to themselves in a diagram, as it says there. Vectors can be added in any direction. When two or more vectors are added, the sum is independent of the other of the addition. This idea is demonstrated by a runner practicing for a marathon along a city street as represented in the figure here. The runner executes the same forward displacement in each case, but the order is different regardless of which path the runner takes. The runner will have the same total displacement expressed as d, as you can see there. Similarly, the sum or the vector sum of two or more vectors is the same regardless of the order in which the vectors are added, provided that the magnitude and direction of each vector remain the same. To subtract a vector, add its opposite. Vector subtraction makes use of the definition of negative of a vector. The negative of a vector is defined as a vector with the same magnitude as the original vector but opposite in direction. Multiplying or dividing vectors by scalar result in vectors. This will be a main idea review so that you can answer. The answers will be posted in the next video. Thank you for watching, and don't forget, physics is life.